Hello and welcome students. This is a lecture on planes, and in this lecture of planes we are going to study angle between two planes. Now the statement for the same goes as follows. Here I have written, see, the angle theta between the planes, which between the planes, I'm sorry, it is plural. Angle theta between the planes, which two planes? The first plane here is r bar dot n1 bar equals to p1. You know, the equation of a plane will always come in this form. You know, r bar dot n bar equals to a bar dot n bar, right? Where n bar is the normal to the plane, right? What is this? Is plane. This is the point A. Then here you have the normal vector n bar, and then you take a variable point r. So AR bar is perpendicular to n bar. So when you simplify this, AR bar dot n bar is 0. You get r bar dot n bar is equal to a bar dot n bar. Now see, this a bar dot n bar will give you a constant. Okay, that will come some number. So always remember that equation of a plane will come in the form r bar dot n bar equals to some number. Now here I am writing n1 bar because there are two planes. So for one plane, the normal is n1 bar. So an RHS is some number p1. And then there is another plane. Which is r bar dot n2 bar is equal to p2. So angle between these two planes is given by cos theta is equal to this n1 bar dot n2 bar upon mod of n1 bar mod of n2 bar. See students, you don't put any point dot here, no, because see, when you are putting a dot here, you mean the dot product of these two vectors, and down here you have the magnitude of those two vectors multiplied. So you don't put that dot here. Some students have a habit of writing dot here also. That is wrong, please. And if this theta is acute angle, this is the way you give angle between the two planes. Okay, where n1 bar and n2 bar, what are they? They are the normals to those two planes. Okay, and if this theta happens to be, the angle between the two planes happens to be an acute angle, then what you will do, you will put this in a mod. Why? Because if theta is acute, then cos of acute angle will always be positive. So you will just make sure that you end up getting a positive number. That is how it is. You end up getting a positive number. Fine. So this we have to prove. See, we have to prove this. Students, it is very simple. Now, how do I derive it? I will tell you. Listen, always remember one thing, that angle between, remember one thing, this statement is very important. Angle between two planes is equal to angle between their normals. Angle between their normals. Okay. This is very important, students. What it is? Always remember, angle between two planes is equal to angle between their normals. Yes. Now this statement, is slightly tricky, but then one might think that how is this possible? See, I'll tell you this. Suppose you got an angle here. Suppose you got a plane here. Okay. Students, you are looking at a plane from the front side. See, I'll tell you how it is. Think of a how do I tell you? Think of a notebook, actually, notebook. So you open the notebook. What do you have here? See, here you have pages. Here you have pages now. See, the notebook is you have pages like this. See this, you have pages, plenty of pages you have like this. You know, the pages one over the other. See, you have the pages, right? You have the page. Okay, now how do you shut the notebook? You will shut the notebook like this, you know. This way you will shut it. And when you shut the notebook, you will see something like this, you know. When you shut the notebook, then you will see the notebook is closed. You will see that the notebook is closed. And you see only this part. You see only this part. There are plenty of pages. So when you shut the notebook, what will happen? You know, this thing will not be in the picture. You will not have this part. You will not have this part because you shut the notebook. Yes. But when you open the notebook, how you open the notebook? You will open the notebook like this. Okay. So when you open the notebook, what you will see? You will see this. Okay. Now what I'm trying to tell you is, students, look, think of those two thick card papers, you know, which are the cover of the notebook, which are the cover of the notebook. So those two covers of the notebook are nothing but two planes. You see this? They are two planes, yes, and you have to get the angle between those two planes. See, you have to get this angle. You have to get this angle theta. So here we have two planes. I name these two planes as, see, this is plane alpha 1, this is plane alpha 2. Okay, two planes alpha 1 and alpha 2. I want to get the angle between these two planes. Now see, for plane alpha 1, the normal is n1. See, this is normal to plane alpha 1, that is n1 bar. This is normal, you know, perpendicular to plane alpha 1, you have normal n1. Remember, students, you are looking at the plane from front. It is the front view. It is the front view. That is the reason that you see the plane as two lines. You know, this is alpha 1. And then normal to plane alpha 2 is n2 bar. It is n2 bar. It can be anywhere, not necessarily here only. You know, it can be even here. It can be anywhere. It can just be anywhere. Okay. It can be just be anywhere. Okay, what I will do, you know, students, these two, let me take more, let me take the plane in such a way that it looks more practical, you know, this way. Okay, the plane is, it is, this plane look like, these planes look like lines because you have the front view. You are looking from the front. Okay, you can see only the edge. This is alpha 2 plane. This is plane alpha 2. The normal to this plane is n2 bar. You see this? This is normal, so it is 90 degree. It is n2 bar. This is n2. Okay. Now see, students, let this angle here, let me take this angle here as alpha. Let me take this angle here as omega. Okay, I take this angle as omega. The angle between two planes is theta. The angle between two planes is theta, and angle between their normal is omega. Okay. Now what I do is, here you have 90 degree. This is also 90 degree. Let me take this point as O. This is A, this is B, and this is point C. So what do you have? You have OABC is a quadrilateral. It is a quadrilateral. Yes, OABC is a quadrilateral. Therefore, you know that sum of all the interior angles of a quadrilateral is equal to 360 degree. So I have 90 degree plus 90 degree plus 90 degree. See, this 90 degree plus this 90 degree plus theta plus omega is equal to 360 degree. So what I got? I got theta plus omega is equal to 360 minus 180, that is 180 degree. This is equation number 1. Okay. Now, my dear students, I take this angle as uh, I take this angle as delta, right? Now look at the picture here, and from the picture, see what you can say. You can say that these two angles, delta and omega, they are supplementary angles. Okay, they are angles in linear pair. They are supplementary angles. Delta plus omega will also be 180 degrees. So in the next step, I will write also from the diagram what you have delta plus omega is equal to 180 degree. Yes, this is equation number 2. Now from 1 and 2, what you see, students, you see that, see, theta plus omega is 180 degree, delta plus omega is also 180 degree. It means the left hand side will be equal to, see, if the RHS are equal, obviously the LHS have to be equal. Therefore, from 1 and 2, you can say theta plus omega is equal to delta plus omega. Now, can I cancel this omega? Definitely yes. This omega would be cancelled. So what you have theta equals to delta. You have theta equals to delta. What was theta? Theta was the angle between two planes. And what is delta? You can check. Delta is angle between N1 bar and N2 bar. You can check here. Delta is angle between N1 bar and N2 bar. Got that? So here what I have, I will say, therefore, we can say that, angle between two planes is equal to angle between their normals. Angle between their normals. I hope it's clear to you. So here, students, see, now having done that, the angle between two plane is same as angle between their respective normals. Having done that, now if I am given, now you understand, it is self-explanatory. I have two planes, plane alpha 1, whose equation is r bar dot n1 bar is p1, and this is plane alpha 2, whose equation is r bar dot n2 bar is equal to p2. What will be angle between the plane alpha 1 and plane alpha 2? It will be the angle between their normals, normal vectors. Okay. So if I want to get the angle between plane alpha 1 and plane alpha 2, I will have to get the angle between their normals. And how do I get angle between any two vectors? See, n1 bar and n2 bar are two vectors. How do I get the angle between any two vectors? It is this formula. Okay, any two vectors, if you want to get the angle, what should you do? You should get their dot product. Okay, so see here, I will write here n1 bar and n2 bar are normals to the planes alpha 1 and alpha 2 respectively. Equation of alpha 1 is r bar dot n1 bar equals to p1. Equation of alpha 2 is r bar dot n2 bar equals to p2. Okay, see here, I write n1 bar dot n2 bar. n1 bar dot n2 bar is equal to mod n1 mod n2 cos of theta. Okay, that is, I'm finding I'm finding C, where theta is angle between the two normals. What I'm writing here, see here I will write where theta is angle between, please understand here theta is angle between two normals, where theta is angle between two normals, that is n1 bar and n2 bar. But as I know, if I'm getting angle between two normals, the same will be the angle between their planes. Okay, so here I got cos of, so what is cos of theta? Therefore cos of theta is n1 bar dot n2 bar upon mod of n1 bar mod of n2 bar. See, I got it. So where theta, what was theta? See, when you wrote this, you said where theta is the angle between two normals. But you know, angle between two normals is same as angle between two planes. Okay, so the same formula is working for the angle between two planes. That is why the same formula. Okay, now this is done. Also working, also holds true for angle between the planes. Okay, fine. Now see, if theta is acute, I write here, if theta is an acute angle, theta is an acute angle, then what will happen? Then cos of theta will be mod of n1 bar dot n2 bar upon mod n1 bar into mod n2 bar. Okay. Now see, suppose I am given, okay, let me write, suppose I am given here, let n1 bar be given as a1 I cap plus b1 j cap plus c1 k cap, and n2 bar, obviously, why not? They are normal vectors, so they can be given like this. N2 bar is a2 I cap plus b2 j cap plus c2 k cap. Okay, then what will happen? Cos of theta will become, see, cos of theta will become, I'm taking the formula for acute angle only. Now see, what do you have here? You have n1 bar dot n2 bar, that is this dot this. Now you know the dot product of these two, you will get a1 a2 plus b1 b2 plus c1 c2 in the numerator, and in denominator you have, what do you have in denominator? You have mod of n1 bar. So now magnitude of n1 bar will become a1 square plus b1 square plus c1 square and square root of a2 square plus b2 square plus c2 square. Okay, very good. Now suppose if I am given that, okay, students, I would like to add one more thing here. Here I have written where theta is the angle between two normals, that is angle between two planes, that is angle between the planes. Why? Because you know just now we proved angle between two planes is same as the angle between their normals, that is angle between the planes. Okay, so now see students, if I am given that two planes are perpendicular to each other, okay, so here I write here case 1. Okay, I write here case 1. What is case 1? I write when the normals, when the planes are perpendicular to each other. You know, if the planes are perpendicular to each other, what will happen? Just imagine. If the planes are perpendicular to each other, automatically the normals will become also, see, these are planes and they are perpendicular to each other. They are at 90 degrees. Okay, the angle between them is what? 90 degrees. The angle between them is 90 degrees. So what will happen to their plane, their normals? See, the normal of this will be this way, perpendicular to this plane. See, this angle is 90. Okay, and normal to this will be, this plane will be this way, perpendicular. So what you notice? You notice that normals are also perpendicular. You see this? The normals are also perpendicular. So if the two planes are perpendicular to each other, what will happen? What will happen? When the two planes are perpendicular to each other, theta is 90 degree. And if theta is 90 degree, you know that is cos of theta will be cos 90, that is equal to 0. And see students, if the left hand side is 0, it means the numerator has to be 0, then only it can be 0. So I will write therefore a1 a2 plus b1 b2 plus c1 c2 is equal to 0. This is what will happen, when the two planes are perpendicular. When the two planes are perpendicular, then a1 a2 plus b1 b2 plus c1 c2 will be equal to 0, where a1 b1 c1 are DRS of the normal to the first plane, a2 b2 c2 are DRS of normal to the second plane. Fantastic. Now I go for case 2. See, what is case 2? Case 2 is if the two planes are parallel to each other. Now see students, if the two planes are parallel to each other, what will happen? See, very simple. I have two planes which are parallel to each other. See, I have two planes which are parallel to each other. See, this is one plane, and just above this plane, I have another plane which is parallel to it. See, these two planes are parallel to each other. Now, what will happen? If the planes are parallel to each other, then what will happen is, look at the normal to this plane. It is normal to this plane. And look at normal to this plane. It is normal to this. What do you notice? If the planes are parallel to each other, the normals are also parallel. The normals are also parallel. You understand? If I have this plane as alpha 1 plane, so this is n1 bar, which is perpendicular to plane alpha 1. This is alpha 2 plane, so this is n2 bar, which is perpendicular to plane alpha 2. Now what you are noticing that these two normals are also parallel to each other. And if the two normals are parallel to each other, what will happen? What will happen? One normal will become the scalar multiple of other normal. Yes. If the two vectors are parallel to each other, they are collinear to each other, then one vector is a scalar multiple of other vector. That is true. One vector is a scalar multiple of other vector. I write here case 2. Case 2 is, I write when the planes are parallel to each other. They are parallel to each other. Now, when the planes are parallel to each other, then the normals n1 bar and n2 bar are also parallel to one another. Therefore, n1 bar can be written as k n2 bar. You see this? Or n1 bar can be written as m n2 bar. M n2 bar. Okay. What is m? Where m is a scalar. Where m is a scalar. Now see students, if m is a scalar, see what will happen. n1 bar, what was n1 bar you wrote? You wrote n1 bar as a1 I cap plus b1 j cap plus c1 k cap equals to M, and what is N2 bar? A2 I cap plus B2 J cap plus C2 K cap. Okay, what I will do is I'll multiply this M inside. So it will become MA2 I cap plus MB2 J cap plus MC2 K cap. And this side what I have A1 I cap plus B1 J cap plus C1 K cap. Now, since the vectors are equal, by equality, the coefficient of I cap here is same as this. Coefficient of J cap here will be same as that. So what I have therefore A1 is equal to MA2. This gives me A1 upon A2 is M. Similarly, B1, see B1 J cap. So B1 is equal to MB2. So I have B1 upon B2 equals to M, and C1 is equal to MC2. So I have C1 upon C2 equals to M. Therefore, A1 upon A2 equals to B1 upon B2 equals to C1 upon C2. Because all are equal to M, this is the condition for parallel planes. So please understand, students, when you have two planes having their DRS normal, when you have two planes having the DRS of their normals as A1, B1, C1, A2, B2, C2, and the planes are perpendicular, then what will happen? Then A1, A2 plus B1, B2 plus C1, C2 will be 0. This is the condition for perpendicular planes. And if the same planes are parallel, then A1 upon A2 will be equal to B1 upon B2 equal to C1 upon C2. Okay. I hope you all followed this. These are two important points which you should be writing. Please write it. So here I have a question for you students. As such, the number and the exercise are very trivial. They are not that important. See, this is exercise 6.4 and question number 1. But what is important is the type of question. See, what are we given? They ask us to find the angle between planes. Angle between planes. They provide us two planes. Look at the first plane. R bar dot N1 bar equals to P1. The next is R bar dot N2 bar equals to R bar dot N2 bar equals to P2. You know this P1 and P2 are insignificant if you are finding the angle. Got that? So here I will write, I know the formula. I'll write here answer. I write here the angle theta between the planes is given as cos of theta equals to mod of N1 bar mod N2 bar upon magnitude of N1 bar multiplied to magnitude of N2 bar. Okay, I write here. Here N1 bar is I cap plus J cap plus 2K cap. Say, means we are assuming N2 bar is 2I cap minus J cap plus K cap. Again, say, this is our assumption. Therefore, here I will write the acute angle, please, the acute angle theta. So, what is it? Cos of theta is, student, it is, what is it going to be? It is N1 bar dot N2 bar. That is, 1 into 2 plus 1 into minus 1 plus 2 into 1. I'm just taking the dot product of these two. 2 into 1 upon square root of the magnitude of n1 bar, 1 square plus 1 square plus 2 square into square root of 2 square plus minus 1 square plus 1 square. So what do you have? You have cos theta equals to, you can check here, you will have 1 into 2 is 2, 2 plus 2, 4. So you have 2 minus 1 plus 2 upon, here what you have, 1 plus 1 plus 4. So 1 plus 1 plus 4, and down here 4 plus 1 plus 1. 4 plus 1 plus 1. So that is equal to, you got 3 upon root 6, that is 2 root 6. Okay, that is equal to, 3 upon 2 root 3 into root 2. I can write root 6 as root 3 into root 2. So that is root 3 upon 2 root 2. This is, so I have here cos of theta as, therefore cos of theta is equal to, this is positive. Students, I put that in mod because I wanted to have the positive of this, but then it is anyway positive, 2 root 2. So what is theta? Theta is cos inverse of root 3 upon 2 root 2. This is the answer. I hope you all followed it. Please copy this.
Sir, 1/2.
Okay, so students, here I'm extremely sorry. I committed a mistake. See, this is you know what, by mistake I considered here a plus sign, but it is product. Okay, it's a blunder that I committed. I'm sorry for it. So it is not root 6 plus root 6. What it is root 6 into root 6. Okay, so the answers will change here. The answers will change here. So what you will have root 6 into root 6, that is 6. So this is 1 by 2. So mod of 1 by 2 you will have. So this is 1 by 2. And cos theta is 1 by 2. So theta is pi by 3 or 60 degrees. Thank you. Okay, students. So the next topic that we are doing is angle between a line and a plane. So students, see here I have a plane alpha and I have a line L. Okay. The equation of this alpha plane is, say, R bar. Equation of the alpha plane is, it is R bar dot n bar equals to P. R bar dot n bar equals to P. Okay. And see, if I'm writing R bar dot n bar as P, don't consider this to be P of that normal form. It is not the perpendicular distance. Why? Because this is not n cap. Please, it is not n cap. It can only be perpendicular distance if you have R bar dot n cap. This has to be the n cap unit vector. So here I have alpha plane whose equation is this. Okay. And then I have another line, line L. And what is the equation of a line? It is R bar equals to A bar plus lambda B bar, right? R bar is A bar plus lambda B bar. Okay. Now, when I say R bar dot n bar equals to P, let us talk about the plane first. Okay. So the plane here is alpha plane, what is this n bar? You know, this n bar is a normal vector to the plane. So it is actually this, you know, n bar is this. It is normal vector to the plane. It is perpendicular to the plane. Okay. This is 90° to the plane. This is 90° to the plane. It is like this. Next. If I have the line is r bar equals to a bar plus lambda b bar. You know, this a bar is the position vector of a point A on the line, you know. And what is b bar? You know, this b bar is a vector which is parallel to the line. We all know that b bar is a vector parallel to the line. This is b bar. Okay, this is vector b bar. Fine. Now, students, here what are we working on? We are working on angle between the line and the plane. So, you know, this line is intersecting the plane. Now, where it intersects the plane, say this point here I have, and this point is, say, the point of intersection, it is, say, point B. It is point B where it is intersecting. Okay. So, the line and the plane meet each other at point B. Now, this line, if I'm projecting, you know, if I project the line, then I will get the projection of line on the plane. And see, this is the projection line. This here is the projection line. You know, it is this way. It is the projection line. Remember that this projection line is on the plane. It is on the plane. It is, you know, you can think that there is a bulb here. Okay, just above this, you know, there is a bulb here, and because of that bulb, you know what is happening? You are getting the image of line on the plane. You are getting the shadow of that line on the plane. Okay, fine. So angle between, please understand, students, that angle between the line and plane is nothing but angle between the line and its shadow that is on the plane. Are you getting? When you say the angle between line and plane, basically it is the angle between the line and its shadow, the line and its projection on the plane. This angle you want to find. Okay? Very good. If I'm asking you, students, tell me what will be the angle between the normal with this image of what will be the angle between the normal and the shadow of the line which is on the plane? Definitely this is going to be 90°. What will this be? This will be 90°, because we all know that normal is perpendicular to the plane, and this shadow line, that is the projection line which we have, that is on the plane. So automatically n bar is perpendicular to that. N bar is perpendicular to this. Now, see here, students, I will write this angle as, tell me all, what do you think will this angle be equal to? This angle. This angle will be pi by 2 minus theta. Pi by 2 minus theta. See, if this angle is pi by 2 minus theta, that is the angle between normal and the line. Please understand. We are interested in the angle between line and the plane, which is theta. So I want angle theta. If angle between the line and plane is theta, angle between line and the normal to the plane will be 90 minus theta. And if the angle between line and the normal is 90 minus theta, I can say the angle between B bar and N bar is also 90 minus theta. Why? Because B bar is parallel to line. Okay. On the other hand, what we can do is, see, this is your n bar, this is your n bar, yes. What is angle between n bar and line? Pi by 2 minus theta. See, if I shift this here, what do you think? If I shift it here, see, here it was, okay? If I shift it like this, don't you think that this angle is also pi by 2 minus theta? Yes, so this is also pi by 2 minus theta, and this is your n bar. So I can say that angle between n bar and b bar is pi by 2 minus theta. So see here what I will write. I will write therefore, see, now I begin with, I write here n bar dot b bar is equal to mod n bar into mod of b bar into cos of angle between them. What is angle between them? Pi by 2 minus theta. I'm taking the dot product of n bar and b bar. Okay. So I have therefore n bar dot b bar upon mod n bar mod b bar is equal to cos of pi by 2 minus theta, which is sine of theta. And this is it. I got the angle between the two. That is, I got the angle between the line and the plane. See, this is the formula. How to give the angle between line and plane? If the line is r bar is equal to a bar plus lambda b bar, and the plane is r bar dot n bar as p, then angle between the line and plane is given by sine of theta, where theta is the angle between two. Sine of theta is equal to n bar dot b bar upon mod n bar mod b bar. Okay, I repeat again. Everybody listen to this. I repeat again. The line is r bar is equal to a bar plus lambda b bar. R bar is equal to a bar plus lambda b bar, where b bar is the vector parallel to the line. The plane is r bar dot n bar as p, where n bar is the normal to the plane. If these are the two lines and planes, and the angle between them is theta, 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 then the angle between them is given by the formula sine theta is equal to n bar dot b bar upon mod n bar mod b bar. I hope you followed it. Now, there are some pointer students which I would like to add here. So let us go one by one. So let us take off the case one, and the case one is, I write here, when line L is perpendicular to plane alpha. Now see students, if the line L is perpendicular to plane alpha, in that case, what will happen? Just try understanding. Just try to get this. You know, this is your line L. This is your line L, right? Yes. What is happening? It is becoming perpendicular to plane alpha. It means the line is perpendicular to the plane alpha. You see this? The line earlier was this way, this way. Now the line is perpendicular to plane alpha. It is this way. And see, if the line is perpendicular to plane alpha, b bar is a vector parallel to the line. So what will happen? That b bar will come along the line. The b bar will come along the line, and it will become parallel to that. B bar will become parallel to n bar. You understand? B bar will become parallel to n bar. That is important. Okay, that is important. So here is case one. What have I written? When line L is parallel to plane alpha. So I will write in this case, in this case, you know, B bar will be parallel. B bar will be parallel to N bar. Okay. Now suppose I am given B bar as I am given as a A1 I cap plus B1 J cap plus C1 K cap, and I'm given n bar. Obviously, these are vectors, so they'll be given like this. You know, they can be given in the as a linear combination of I cap, J cap, K cap, and n bar. Suppose I'm given as A2 I cap plus B2 J cap plus C2 K cap. So what will happen? Since A bar and N bar, they are parallel. When the two vectors are parallel, then what will happen? One vector will become a scalar multiple of other vector. So, like you can write N bar is equal to M times V bar, and then all that you will do. And what you will get, that is you will get A1 upon A2 equals to B1 upon B2 equals to C1 upon C2. See, students, you don't have to actually remember all these all the time. You don't have to, learn by rote. No, it is, I explain this so that the idea is always clear. And when you come across any question, okay, whether it is your MCQ based type question or it is subjective, if you come across anything like this, you can always give that a thought. You shouldn't feel that I haven't done, neither should you feel that I can't do it. No, you can do it. You have to give that a thought. The concept is there with you. You have to just work on it, okay? And you can do it. So this is case one, when the line is perpendicular to the plane. When the line is perpendicular to the plane, remember, the line becomes parallel to the normal of the plane. Now I go for case 2. See, what is case 2? In case 2, we have, students, when line L is parallel to plane alpha, what will happen? You all know. This line which is here, this way, this will become parallel to alpha. It means it will actually not cut the plane alpha. The line is parallel to alpha. It's going to be like this. It will not cut it. Now, when the line is parallel to alpha plane, you see that it becomes perpendicular to normal. It is perpendicular to normal. And if the line is perpendicular to normal, definitely the vector which was along the line, this B bar, what will happen to that? That will also become perpendicular to vector N bar. So B bar and N bar have become perpendicular. Now see, students, if B bar and N bar become perpendicular, the next thing that you write is what? Therefore, see, B bar and N bar are perpendicular. I will write in this case, B bar, B bar will be perpendicular. B bar will be perpendicular to N bar. Now, if B bar is perpendicular to N bar, therefore B bar dot N bar is 0. You have B bar, you have N bar. What will you write? You will write therefore A1, A2 plus, I'm sorry, you are not supposed to put that dot here. Therefore, A1, A2 plus B1, B2 plus C1, C2 is equal to 0. I hope you all followed it. Please copy this. So students, here we have a question, and in this question, see, what does it say? In this question, it says that find the angle between the line. What is the line? R bar equals to I cap plus 2j cap plus 2k cap plus lambda times 2I cap plus 3j cap minus 6k cap, and the plane R bar dot 2I cap minus j cap plus k cap is equal to 0. Okay, we have to get the angle between two, that is angle between one line and a plane. So here, see students, I will write, see the answer. What I know is, see, the given line is this. So this is, this is B bar. You see this? This is B bar, the vector parallel to the line. And this is N bar. This is N bar. What does it mean? It means it is the normal vector perpendicular to the plane. I will write here. The angle theta between the line and the plane is given by sine of theta equals to b bar dot n bar upon mod b bar mod n bar, sine of theta. Okay, because it is cos of pi by 2 minus theta, which becomes sine of theta. Got that? And then I will write here, that where b bar is vector parallel to line and n bar is vector perpendicular to plane. So by having said this, now what I know is what is b bar and what is n bar. So this is my equation number 1. See here. I write here, what is b bar? B bar is this, 2i cap plus 3j cap minus 6k cap, say, and n bar is, this one is n bar with in the equation of the normal, 2i cap minus j cap plus k cap. This is also say, that is, that is b bar and n bar, which I'm writing. It is the notation, symbols. So here what I have, therefore, or okay, don't write say here because we have already written b bar and n bar and they are there. So here what I have, so I will write therefore sine of theta becomes, see, b bar dot n bar, b bar dot n bar. B bar dot n bar is this vector dot this vector. What will that be equal to? It will be 2 multiplied to 2, 2 into 2 plus 3 into minus 1 plus minus 6 into 1 upon square root of, you see this, square root of, what do you have? You have here mod of b bar. So 2 square plus 3 square plus minus 6 square. And you got on this side, you got 2 square plus minus 1 square plus 1 square. So you got here 2 into 2 is 4 minus 3 minus 6. Okay. So, and here you have mod of 4 plus 9 plus 36 and square root of 4 plus 1 plus 1. So what you got, therefore sine of theta is, you get therefore sine of theta as therefore sine of theta is minus 5 upon okay, students, see, we need to be, we are asked the acute angle, okay? So we need to be writing this in mod right from the beginning. Okay, we need to be writing this in the mod. You know what is happening? If you are not writing in mod, then you might get this angle. You might get this angle, which is, see, I'll tell you that. This part of the line is So you might get this angle, which is reflex angle. So you might get angle between line and the plane. So you might get this angle, which is more than 180. You see this? So that you will get the negative value. You will get the negative value. So you'll have to put a mod. So what it will get me now? So -5, and here you have root of 49, root of 49, root of 6. That is equal to sine of theta is 5/7 root 6. So theta is equal to sine inverse of 5/7 root 6. This is the answer. Copy this. Students, the next part that we are taking is perpendicular distance of a point from a plane. Now in this, what are we going to have? See, we will have a plane here. See, this is a plane that you have. Say this is alpha plane, and its equation is r bar dot n bar equals to p. Okay, it is not n cap, please. R bar dot n bar equals to p. And then I have a point in space. I have a point in space somewhere. This is the point that I have. Okay, this point is in space. This point is, say, P, capital P, x1, y1, z1. I want its distance. I want its perpendicular distance from the plane. I want its perpendicular distance from the plane. Okay, that is, this is a foot of perpendicular. This is, say, the foot of perpendicular M. So what I want PM. I want length PM. And as it is length PM, it will always be positive. So it will be in a mod. See here. I'll tell you how should you be writing. This is very easy formula. Very, very, very easy formula this one is. And in order to make it more simpler, I shall give you one example, one illustration, which we have done in 11th standard when we studied the topic of lines. Okay, straight lines in plane. Remember, students, when we studied straight lines in plane, I'm not talking about straight lines in space. I'm talking about straight lines in plane. Okay, that is, I'm talking about those lines which are being studied on 2D plane. That is y-axis, x-axis. This is y-axis, this is x-axis, this is, and this is y. Now here, if you remember, a line in general, a line equation is given as ax plus by plus c equal to 0. A line in general has equation ax plus by plus c equals to 0. Okay. Now, when I have a point p x1 y1, I'm talking about a line in general had this equation. A line in general. A line in general had this equation. As such, there were many forms, but this was the equation of a line in general form. Okay, this is the general form of equation of a line in plane. As such, you had many forms. You had slope-intercept form, which was y equals to mx plus c. You had double intercept form, which was x upon a plus y upon b equals to 1. Then you had the slope-intercept form, that is y minus y1 equals to m into x minus x1. Then you have double intercept form, that is y minus y1 upon x minus, then you had 2-point form, that is y minus y1 upon x minus x1 is equal to y2 minus y1 upon x2 minus x1. So you had all these different forms, but we are interested in one form, and that is the form in general. Okay. The equation of a straight line, which is in 2D, equation of a straight line in 2D, it had its equation in general given by this form. Okay. Ax plus by plus c equal to 0. Now, what I'm trying to tell you is, can you recall when you had a point in plane, some point in plane you had, which was px1, y1, px1, y1, and you wanted to get its perpendicular distance from this line. You wanted to get its perpendicular distance from the line. That is, say this is say M, point M. M is the foot of the perpendicular on the line. So what was the formula for PM? Do you remember? Can you recall what was the formula for PM? That is perpendicular distance of a point from a line when the line was in a plane. And this was the general equation of the line. Can you recall it? Just think on it. Very good, students. I'm sure many of you must have got it. And the formula goes as this. See, what we do is we write the equation of the given line such that the right hand side is 0. And then the left hand side, which is a linear algebraic expression in x and y, we write the whole LHS in the numerator, replacing x by the x coordinate of point and y by the y coordinate of point whose distance is expected. So what we will get A, don't write x, write x1, plus B, don't write y, write y1, plus C. ax1 plus by1 plus c, denominator you write square root of a square plus b square. Now see, students, as you do this for the distance of a point from line in plane, you do exactly the same way for distance of a point from a plane in space. This time what we have space. In space what we have a plane, then we have a point in space, and then I want the distance of this point from this plane. Now listen, what is r bar? R bar is what is r bar? If I ask you what is r bar, you would say that r bar is nothing but the variable point position vector. So r bar, can I write r bar as xi cap plus yj cap plus zk cap? Yes. What is n bar? What is n bar? N bar is a vector perpendicular to the plane. Yes. So can I write n bar using its position vector? Can I write n bar using its position vector? That is a1 i cap plus b1 j cap, or ai cap plus bj cap plus ck cap, and right hand side is p. So now what it will become? It will become ax. This is dot product, so a into x, ax plus by plus cz equals to p, right? So this is ax plus by plus cz minus p equal to 0. I can replace minus p by plus d, okay? Some another constant. So ax plus by plus cz plus d is equal to 0. See, this is the equation of a plane in general. Okay, so the equation, see, whenever I have a question where they will ask me to get the distance of a point from a plane, what I will do first, I will write the equation in this form, which is the Cartesian equation of the plane. It is the Cartesian equation of the plane. I will write the equation in this form. And then, see, once I have this, so here, see, the equation of the plane is what it is. It is ax plus by plus cz plus d equal to 0. The right hand side I will make 0. Now what? Very, very, very simple. See, Pm, you will write the whole LHS in the numerator only. Don't write x. In place of x, write x1. So this becomes what? This becomes ax1 plus by1. Don't write y, right? Y coordinate y1 plus c z. Don't write z. Write the z coordinate of the point. cz1 plus d upon square root of a square plus b square plus c square. This is it. This is it. I hope it's clear to you. Exactly what you had done in 11th standard. See, the line you have ax plus by plus c equals to 0 because there is no z orientation. For the plane, what you have ax plus by plus cz plus d equals to 0. I hope it's clear to you, students. Please write it down. So students, just now we studied how to find the perpendicular distance of a point from a plane. Now based on that, here we have a question. Very simple question. Find the distance of the point. Find the distance of the point 4i cap minus 3j cap plus k cap. So this is the position vector of the point with respect to origin. So the coordinates will be 4 comma minus 3 comma 1. So this is the point. From the plane, they want the distance from the plane. What is the equation of the plane? R bar dot n bar equals to P. You see this? But what I will do, I will write this equation in Cartesian form. Okay, so I will write here. See, how do I write the solution? I will start my solution as follows. I will write the given point, the position vector of point is 4i cap minus 3j cap plus k cap. Therefore, the coordinates of point are 4 comma minus 3 comma 1. Okay, and I will write this as P. I'll write this as capital P, and here I write say, means that is my assumption that it is P. Okay, the plane is, the equation of the plane is, the equation of plane is what it is. It is R bar dot, this one, you know. So R bar dot 2i cap plus 3j cap minus 6k cap equals to 21. Now, you know, students, that what is R bar? R bar is, that is, you know, R bar is always xi cap plus yj cap plus zk cap dot 2i cap plus 3j cap minus 6k cap equals to 21. So this will become 2x plus 3y. You know the dot product of these two vectors. So you have 2x plus 3y minus 6z equals to 21. That is minus 21 equals to 0. Okay. So students, see, I got the coordinates of the point. Yes. I got the equation of the plane in Cartesian form. Yes. Now, can I get the perpendicular distance? Yes, I will write. Therefore, see, therefore, the perpendicular distance, or the distance rather, distance of point from the plane equals to, see students, mod and what? See, 2x, don't write x, right? 4. 2 into 4 plus 3 into, don't write y, write the y coordinate, minus 3 minus 6 into z, don't write z, Write the z coordinate. That is 1. Minus 21. Some students will forget to write minus 21. Please, you have to write complete LHS. You have to write complete LHS upon square root of 2 square plus 3 square plus minus 6 square. So now what you have here distance equals to mod of, this is 8 minus 9 minus 6 minus 21 upon square root of 4 plus 9 plus 36, that is equal to mod of, this is minus 1 minus 7 minus 28. Okay, minus 1 minus 7 minus 28 upon square root of 49, which is 7. So distance is equal to mod of minus 4, that is equal to plus 4. This is the distance. I hope you all followed it. Tell me, students,